Hello everyone. Welcome to another first flight. In this week, we have another interesting project, and we are going to be talking about interesting parts of this smart contract. As always, our smart contracts for this project has its own thematic, and we are going to be talking about how kernel smart contract works as well. So let me share my screen over here and let me present to you first slide number 16, Mafia Takedown. An undercover anti-mafia agency discovered a protocol used by the mafia. In several days, a raid will be conducted by the police, and we need as much information as possible about the protocol to prevent any problems. But the anti-mafia agency doesn't have any Web3 experts on their team. Hawks, they need your help. Find flaws on this protocol and send us your findings. So basically, this smart contract is managed by a criminal organization, and you have to put yourself the hat as the investigator and take as much as information out of this smart contract, especially which flaws can be exploited to stop these mafia agents. So, as always, please be sure to open this GitHub repo and clone it into your computer. I already did. Don't forget you need to compile everything with the make command. Actually, I'm going to make this bigger. And you can use make test to see if everything's going fine. But I have here an error because I may be not on the correct folder, I guess. Never mind. Let's continue here. You have here the details as always, how much experience you are going to get for each one of your findings, the ends log, and the complexity scope. This one is one of the higher ones we had so far, because the first flights we hosted before, I think they were like easier than this one. This is a little bit more complex. And as always, please be sure to read all the documentation here. I'm going to be explaining all of these anyways soon. So let's go to the main core of this project. And once you have cloned it onto your computer, let's go to the README. And we are going to have something interesting called the kernel.sol. A kernel, for you who doesn't know what a kernel is on computer science, is like the core of an operating system. Linux is the kernel of any Linux distribution, or the GNU Linux is the kernel or the core operating system on which you can build upon. In this case, we are using the same approach. We are going to have a kernel, which is going to be the core for all the smart contracts, managing all the requests and all the basic logic on the back. And we can build upon that kernel to create the modules and functionalities we want. In this case, the mafia has used this kernel.sol in order to create their criminal organization. This is a little bit of an extensive smart contract, and actually is not on the scope of this audit. But I'm just going to give you a basic rundown on how this kernel works, because understanding the kernel will help you to understand how the other smart contract works and how they interact with each other. First, we have the kernel contract. Give me a second. Kernel, yeah. This kernel contract is the central contract that manages the installation, upgrade, activation, and deactivation of modules and policies. It also handles role management and the kernel migration. Give me a second. The module contract is an abstract contract that represents a component providing specific functionalities. Modules need to be installed or upgraded by the kernel and can be interacted with by an authorized policy. So We have the base smart contract or the base core for this project, which is the kernel. And in the top, we are going to use these modules. In this case, the modules used by the mafia to do some money laundering. And then we have the policies contract. The policies contract is the one responsible for set the rules and behaviors that can interact with the modules. Policies need to be activated or deactivated by the kernel and can request permissions to access module functions. And then we have the kernel adapter. Let me show you here, kernel adapter. The kernel adapter contract is the one responsible to provide the base for the module and the policy contracts, ensuring they have access to the kernel instance. So basically, we have these modules, which are the added functionalities for the kernel, and the policies which define the permissions for the protocol. The kernel is the main quote unquote operating system that is going to interact with the modules based on the policies or the permissions. With that explanation, we can actually explain how the Mafia smart contract works. First, we have this laundred.sol, which is, as you might expect it, for money laundering. Anyone around the world can deposit money on this smart contract. As you can see here, deposits from anyone is allowed. Any help is appreciated for the organization is appreciated. Moreover, that's convenient for ransom money. So any address can deposit crime money. This is going to call the deposit USDC function, which is on the modules, the money shelf. Actually, let me show you. And this smart contract is going to give you crime money, which is a standard stable ERC20 coin. Let me actually go back to the README to continue here. Give me a second. Also, users have to approve the money shelf contract before calling the function to deposit. As always, standard approval for any transfer, same as you do when you are trading NFTs, for example. Currently, the Mafia does not have a way to control the incoming weapons, so only the Godfather can account for them in real world and assign them to any gang member. Gang members has to withdraw them in the contract before taking them in real life. Since they don't want to lose a finger, they never forgot to do this way. So if we check again the laundrette.sol, we have also these functions here, which are the take guns. And this take guns is only role. And the role for you to be able to take those guns is for you to be a gang member. Otherwise, you are going to be reverted. Also, you can quit the gang, and this quit the gang is not recommended because you know how Mafia works. They don't like you quitting. You can add another member. You can invite your teammates to become another gang member. But remember that the only one who can assign the weapons is the Godfather or the leader of the criminal organization. And let me go back, sorry, to the README over here. Then we have the modules. As I said, the modules are functionalities that are built on the top of the kernel and serves as extra functionalities, as I already said. Modules are internal-facing contracts that store shared state across the protocol, except for view functions. All functions can only be called by an authorized policy. Remember, we have the policies contract, which sets you like the permissions. You need to be or the Godfather or a gang member to be able to interact with the contract, except if you want to deposit. Anyone can deposit. Then we have the weapon shelf. This contract keeps account for the available weapons per member. Here we have the weapon shelf. Again, we just have keycode.grab of the word weapon. Remember, this is supposed to be managed on the real life. The only point here is for the Godfather to assign the weapons. And well, the gang members should actually, as we said before, withdraw them in the contract before taking on real life. Then we have the money shelf. This contract in charge of keeping the USDC and minting burning the crime money. As I already said, you can deposit how much amount of USDC you want, and you are going to get the crime money in return. Users have to approve this contract before calling the landlord function to deposit. Then we have the money vault. In case of any issue on chain or off chain, Money Shell is updated to this contract to protect the money from the justice systems or any other gang. Only the godfather can withdraw. No one can deposit on this contract. So here we have the money vault. The money vault, again, is interacted with the kernel as the other ones. The only one who can deposit here is the godfather. Sorry, no one can deposit. As you can say here, if you try to deposit USDC to this smart contract, is going to automatically revert. And the only one which is going to be able to withdraw from this contract is the godfather. Let me see what else we have here. Then we have the crime money. Again, this is just a standard ERC20 token. Nothing new here with the basic mint and burn functionalities, and of course the role for being able to move the funds inside the smart contract. Also in the scope, we have these deployment scripts. Let me show you the deployer. Here the name is bad, actually. It should say deploy, because this is the test. If you go to the test here, we have the deploy.t.sol, which are the tests. But yeah, on the scope we have the deployer.s.sol. So this is the smart contract responsible for actually launching this protocol to the mainnet or the testnet, whatever you are going to use. Finally, we have the getting started. I'm going to get for granted you already know how to do this. Clone the repo, as I already asked you at the beginning, and use the test. Also, make sure to use Forge coverage to be able to know how many days are covered here, but I don't know why I'm not getting this. Give me a second. I think that it might be a problem on my end because I have to clone twice this. Yeah. I think I have some lack of dependencies. That's why I'm not being able to do this. Give me a second. This is interesting because most of you are going to face the same sort of problems, like trying to clone a repo and not being able to actually perform what the protocol is expecting you to perform because you haven't do something. So I just have to run make install to be sure all the dependencies for this have been installing properly. So on the meantime, this finishes because it seems it's going to take a little bit. Let's continue with the other parts. You have the audit scope. Again, remember the kernel.sol is not on the scope, but understanding how the kernel works is important. We are using Solidity version 0.824. We have the roles. First, we have the godfather. This is the owner, and he or she has all the rights to do whatever they want on the protocol. The gang member can deposit USDC and withdraw USDC in exchange for crime money, transfer crime money between members and the godfather, and take weapons that the godfather assigned to the member. External users can only use the view functions and deposit USDC. Which are the known issues? We have missing events. The mafia knows that nothing is private on blockchain, so view functions will reveal what the mafia owns. That's a problem. And user can deposit on any account, not only gang member accounts. Let me check if this actually already finishes. Oh, okay, this is going to take a lot, but remember to use a Forge coverage in order for you to understand how many functions have been tested on the protocol. So that is going to give you a nice overview on where the vulnerabilities and security flaws might be. As always, we also recommend for you to use this extension called Solidity Metrics. This is going to create a complete inform or report of how the smart contract project is handled. So let me actually show you. If you have the extension installed, you can just make a right click here, click on Solidity Metrics. This is going to automatically create that report for you. Here you are going to have the information of how many lines each smart contract has, the ends log, how many command lines, and the complexity score. The complexity score here is different from what we have on the Codehouse page, basically because this is going to actually take in consideration all of the smart contracts, including the kernel. But as you can see, and as you already know, the kernel is not on the scope. That's why this number is different over here. And what's important for you here to always check is this graph over here, the inheritance graph. As you can see here, this project has actually a really complicated inheritance graph. So the weapon shelf, the money vault, and the money shelf, all they have inheritance from the shelf smart contract. The shelf has inheritance from the module, and the module for the kernel adapter. So what happens? If there is a problem, for example, on the money vault, it means that probably we have a problem on the shelf. On the contrary, happens the same. If we have a problem with the shelf contract, it means that we might have a security vulnerability on the weapon shelf and the money shelf and the money shelf. The kernel doesn't have any inheritance, but is not on the scope, and the crime money is just imports, or it has inheritance for a standard ERC20 token. Let me see if this actually finished. No, it doesn't. Never mind. I hope this basic explanation about this project helped you. Remember to double check how the kernel contract works. This is the core and the base for all the protocol functionality. And even though it's not in the scope, understanding how it works is going to be really useful for you. The kernel contract, however, also has a little bit of messy spaghetti or difficult to understand code. So if you find yourself in troubles trying to understand how the kernel contract works, well, we live on in artificial intelligence era, so you can just go to ChatGPT, for example, go to the kernel code. Where is it? And the SRC kernel. Copy all of this and say, explain to me how this smart contract works. Don't forget to use the quotes. For ChatGPT to understand, you're going to add the code snippet. Hit enter, and this is going to give you a basic explanation on how the smart contract works. Remember not to trust this 100% because ChatGPT tends to at least hallucinate a little bit, but it's going to, at least on the high level, going to give you a basic understanding on how the kernel works. Once you have this basic understanding, you are ready to start finding those vulnerabilities. Something that you might be already thinking about this smart contract is that most of the vulnerabilities might be on the policy side, because, for example, we can trick the smart contract to make to anyone to be able to withdraw funds, for example, and not just the godfather or not just the gang member, etc., etc. Let me actually give a last try for this. Now, this is going to take way too much and is outside the scope of this presentation. Never mind. Thank you for being with me here on this presentation. Don't forget that you can always contact us through Discord if you have any question and you need any help or any part that you don't understand about this project. We hope you can participate and level up your skills as a smart contract auditor, and our community manager, Ecus, is going to be really happy to help you if you have any troubles. So don't hesitate to contact us through Discord. We hope to see a lot of findings for this project and for you to get a lot of experience out of this and prepare yourself to compete on a real competition with actually money on stake. Thank you very much for being with me, and I'll see you on the next first fight. Thank you very much. Bye bye.